This video is to help you to review for the Unit 5 test. Again, remember that the types of questions that we saw in the Unit 5 quiz review will also be on the test. These would just be additional types of questions. Feel free to put whatever notes would be helpful to you into your workbook for using on the test. So the first type is Sue asked 10 people their favorite sport, and this is a line plot where we have the different categories and then the X's represent the person's answer. So we got football, soccer, volleyball, basketball, track. Based on the line plot, what is the probability that the next person who asks will say football is their favorite sport? So what you're doing is what we call experimental probability, meaning you're basing it on what was asked, you're basing it on what occurred. So 2 people said football, so that's our numerator, out of 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 out of 10. Okay, so you're saying how many people said football out of how many people she asked. And then we want to simplify, so we can divide them both by 2, giving us 1/5 as a fraction in simplest form. Then, based on the line plot, what is the mode? Mode is the value that occurs the most, and that would be soccer. Soccer is the answer that occurred the most. Next one, Mrs. Jones calls on the following students, boy, girl, boy, boy, girl. Based on the data, what is the probability as a decimal that the next student she calls on will be a boy? So we had 3 boys called on out of 5 students. And since they want the decimal, we would change that to a decimal by taking the numerator divided by the denominator. So 3 divided by 5, which gives us 0.6, 6/10. Which should make sense because 3/5, of course, is equal to 6/10. And since they asked for the decimal, that would be our answer then. For the next one, if you roll a die, a number cube, and flip a coin, what are the total number of outcomes possible? Well, a number cube has 6 possibilities, and flipping a coin has 2 possibilities, so we multiply to find the total number of possibilities, which is 12. Then it says, what is the probability of 3 heads? Now remember, this is the format for saying what's the probability of getting a 3 on the number cube and getting heads on the coin. So when you see it in this format, it means what's the probability of this and this occurring. Well, the probability of getting a 3 on a number cube is 1 out of 6. And the probability of getting heads on a coin is 1 out of 2. So the probability of getting both those things to occur is 1 out of 12. And again, the 12 should make sense as the denominator because, again, that was the total number of possibilities. Next one, if you own 3 pairs of pants that are blue, tan, and gray, and 3 shirts that are blue, green, and white, what's the probability that you wear something blue today? So you may want to, on something like this, go ahead and even make a list. You know, you could have the blue shirt, or blue pants, I should say, with the blue shirt. You could have the tan pants with the blue shirt. You could have the gray pants with the blue shirt. Okay. You could also have the blue pants with the green shirt. You might not think that would match, but still a possibility. Blue pants with white shirt and blue pants with, well, actually, I probably should approach this a little more logically. Let me do it this way for you instead. I put together all the combinations here that had the blue shirt. Okay. So I probably need to approach it in a more logical fashion than like that. That's the only way to make sure that we don't miss any. So since I've got the blue shirt, let me put down the types of pants again. Blue, tan, and gray. Not to be confused with green, so I have to be careful with that too. And if I'm going to write down those 3 types of pants again, now let's list them with the shirt colors. So I've got all the blue shirts represented. Now let me talk about the green shirts. So here's my green shirt with my blue pants. Here's my green shirt with my tan pants. And here's my green shirt with my gray pants. Okay. Again, now I've represented all the green shirts. Now I need to do my pants with the other choice, which was the white shirt. So it doesn't matter how you do it, but you do want to make sure that you are, approaching it in a logical fashion so you don't end up forgetting something. So I have my blue pants with a white shirt. I have my tan pants with a white shirt, and I have my gray pants with a white shirt. All right, so now let's go ahead and mark those that have a blue in them, which is these. All right, these all have blue in them. So that means I have 5 outfits that have blue out of 9 possible outfits. Now, again, if you think that didn't make sense to you logically, another way you could have approached it is you could have done all the blue pants with the 3 shirts, all the tan pants with the 3 shirts, and all the gray pants with the 2 shirts. As long as, again, you don't forget any and you make kind of a logical list. So the 5/9 is correct then. Next question says, if I have a recipe for 48 cookies, but I only want to make 16, what should I multiply the ingredients by? Keyword, of course, here is multiply. Most people would say, well, 48 divided by 3 is 16, and that's true. But what is the same as dividing by 3 multiplying by 1/3? So that's what they're getting at there. That if you're saying that you would divide by 3, that's the same as multiplying by 1/3. The other way you could have gotten that 1/3 is to say, I want 16 cookies out of 48, and then simplifying that fraction would also give you 1/3. So I want 1/3 as many cookies as the recipe calls for, pardon me. All right, for the next one, if you multiply a number by 5 and then add 6 and it equals 51, what's an equation to represent this and what is the number? So we're multiplying in a number, which we can use any variable at all, just go with n, times 5, and then I'm adding 6, and it equals 51. Okay, so I could write it this way. Let's face it though, we typically try to get away from x for multiplication. So we'd probably write this more likely this way. And again, the reason we try to get away from x for multiplication is because it ends up looking like 2 variables otherwise. So this is really not the best way to write it because of that x. So this would be a better way to write it. And then what is the number? So the question is, what number times 5 plus 6 equals 51? Now, there's a couple ways you could approach it. One is you could subtract 6 from both sides. And then you would get 5n equaling 45, which means n would equal 9. You could do a guess and test. Let's see if it's too low, too high, adjust. At this stage in the game, they will give you ones that come out nicely. Down the road, once you have an algebraic process, you won't always get nice whole numbers, but at this point, they will. So you could do a guess and test to get there as well. Next one, what is the probability of getting 1 and red on the spinners? Well, the probability of getting 1 on that first spinner is 2/3. There are 2 sections out of 3 that have the number 1 on them from here. Probability of getting red here is 1/2. And remember, when we have it set up in this format, it means we want to have both, which means we're going to multiply. So we're going to take our 2/3 probability times our 1/2 probability. Again, you can multiply, then simplify, or simplify, then multiply. I prefer the second, simplify first. So I would divide both top and bottom here by 2 and get 1/3. So the probability of getting 1 and then red on the spinners is 1/3 probability. All right, then you're going to be asked to solve for k. Again, this looks like algebra, but it really isn't because the variable is by itself. So it's just a matter of knowing how to work with the integers. So for the first one, you have subtraction. So you're going to do your keep change. You're going to keep your -3. You're going to change your subtraction to adding, and you're going to change your 12, which was positive, to a -12. So you now have it rewritten, -3 plus -12, which of course is -15. For this one, you do not need to do a rewrite, and that's intentional on my part because sometimes people get in the habit of rewriting with subtraction and they start doing it here, there, everywhere. And they start doing it when they shouldn't, like in an addition problem. When you've got addition, you just leave it just the way it is and say, what is 5 plus negative 14? Which is negative 9. All right, so those are the types of questions. Again, please feel free to ask me if you have any questions. Thanks.